Okay, so arrangements are just the number of ways we can place things in order, okay? And another term for arrangements are permutations, all right? So for example, how many ways are there of arranging three different books on a shelf? And I think the easiest way to consider that, if I've got three different books, well, how many ways or how many books have I got to choose from the first spot on the shelf? I've got three choices. And then if I use one book, I only have two choices. And then if I've placed two books already on the shelf, I've only got one choice left. So 3 by 2 by 1 is equal to 6 choices. So that, I guess, that process is what we call evaluating a permutation. Now, when we've got small numbers, it's relatively straightforward to think about what that answer is. If we want to arrange 7 books, so obviously if I've got 7 different books to choose from, well, obviously I could have 7 in my first choice, 6 in my second choice, 5 in my third choice. Now, for etc., etc., etc. Now, we don't want to have to write that terminology all the time. So instead, mathematically, we come up with what we call a factorial symbol. And that factorial symbol is, if I can see one on here somewhere, not really, it's just there. It's an exclamation mark. So 7 by 6 by 5 by 4 by 3 by 2 is actually the same as 7 exclamation mark, which we read as 7 factorial. Okay, so it's counting down from the number all the way to 1, multiplying the numbers together. Now, tech-free, it's probably reasonable for us to know probably up to 5 factorial. If we sort of work a little bit backwards, we've obviously got 1 factorial is equal to 1, 2 factorial, 2 by 1, which is 2, 3 factorial, 3 by 2 by 1, which is 6, 4 factorial, 4 by 3 by 2 by 1, which is 4 sixes, 24. 5 factorial is just 5 times whatever 4 factorial was, which is 5 24s, which is 120. So probably up to 120 is something we would expect you to be able to work out without a calculator. So for example here, 5 factorial, 5 by 4 by 3 by 2 by 1, which is 120. 10 factorial, I don't have a calculator on me, boys. 10 by 9 by 8 by 7 by 6, 5, 4, 3, 2, 1, 127.20. It gets a bit messy. Is equal to 3,628,800. Okay, so really just this first little part is just becoming aware of and familiar with the factorial symbol and the factorial terminology. 2 quick questions there, have a go at them and we'll move on. What we're more interested in here is the number of ways we can make selections. You know, if I've got 5 different people to choose from, how many groups of 3 can I make? Or, you know, if I want to make a president, vice president, and treasurer, out of a group of 10 people, how many different combinations can we have? So when we make selections, we tend to use that terminology. We talk about combinations, okay? And combinations is where we're coming up with a group of things, and it doesn't matter which order they're in. If I just want to get a group of 3 people, it doesn't matter which group, which order I pick the group, it's the same group. So selections are the number of different groups of objects that we can make, where the order of the objects is not important. Okay, and we call that a combination. So for example, if I've got 4 ice creams and I want to make different double scoop cones, you know, I just want to pick 2 ice cream. Well, it doesn't matter whether it's, you know, vanilla and chocolate or chocolate and vanilla. It's the same double scoop. So we could list all the combinations here. I could have, oh, I can have vanilla and chocolate, vanilla, strawberry, vanilla and caramel. And then I could go chocolate, strawberry, chocolate, caramel, and then strawberry and caramel. So there's 6 different options there, okay? Now, keeping in mind our factorial terminology, what we can actually do is we can come up with what we call a combination. And we can do the same sum by saying we have, how many ice creams, sorry? We had 4 ice creams to choose from, and I want to select 2. So 4C2. So, and it does work. We can just call it 4 choose 2. Okay. And the little formula there that you can see is this one here. That's equal to 4 factorial over 2 factorial, which is that 2 there. And then we work out the difference between 4 and 2, which also happens to be 2 factorial. So 4 factorial over 2 factorial times 2 factorial. Now we know 4 factorial is 4 by 3 by 2 by 1 over 2 times 1 times 2 times 1. And you can see that that last 2 and 1 both cancel off. So I end up with 4 times 3 over 2, which is the same 6 combinations that I had initially. Okay, so our combinations are the number of selections you can make from a group of things. All right, our calculator will work it out. We can see the little instruction here, and you can see the way you can work it out on the calculator. So you go to your math menu, go to probability, select the NCR button, and then you put the number of choices for N. Okay, so how many have you got? And then the next comma, how many numbers you're going to pick. All right, so I know I've got you to do these questions in your book, but for example, 5C3. Now I can write 5C3 because mathematicians like shortcuts. We can just do 5 and 2 without the C sign. So 5, 2 round bracket is equal to 5 factorial over 2 factorial, 3 factorial. Okay, that's the formula by hand, or we just go to our NCR 5, 2. All right, so initially it really is just getting used to the notation, the terminology, and the functionality in terms of your calculator to evaluate these things. So I might just do a couple of these questions just as a bit of examples as well. Have a go at them first if you want. Let's just pick, to try and put it in context of a probability kind of scenario, we might modify some of the questions so we can talk about it. So if we look at, say, question 5, an ice cream parlor has 25 different flavors. How many different 3-scoop ice cream sundaes are available? Okay, so obviously I've got 25 scoops to choose from, and I want to select 3. Now, a nice simple way, so we've put that into the calculator and we can work it out. A nice simple way of evaluating that is the 25. We start with 25, and because I'm choosing 3, I count down 25, 24, 23. I go down 3 numbers, and I divide that by 3 by 2 by 1. Okay, so I count down from 3. So it works out to be the same thing. So the bottom line is 6. 24 divided by 6 is 4 times. So my answer there is 25 by 23 by 24, which you can work out. So that's how many 3-scoop ice creams that I could come up with.